Okay, so second lesson on hyperbolas. Let's start. You know, I love a good multiple choice question. I confess, I do enjoy them. And so let's see if you can figure out for me, here is a graph of y equals 4 over x. What is the value of y when x is minus 2? See if you can get me the answer to this. So whereas x is minus 2 is kind of here. And so if we look on the graph, the answer seems to be minus 2. And if we do it with algebra, we also get minus 2, which makes a lot of sense. And so the correct answer is going to be D. Okay, cool. So that was just a little warm-up. And then in the previous lesson, what we did, I'll just give you a quick reminder before I let you do a question. We spoke about a 4-step process for drawing a hyperbola. Step 1 was determining which quadrants the hyperbola would be in, and the hyperbola's standard form we said was this. And if A was greater than 0, if it was positive, it would be in those 2 quadrants. And if A was negative, it was going to be in these 2 quadrants. And we started by deciding that. We also spoke about finding the asymptotes. So maybe I should do an actual example. So like if I had something like that, the second step was to find the asymptotes, and there are 2 of them. And in this case, they would be those 2 values if I'm looking at that example. And then the third step was to find the intercepts, the y-intercept and the x-intercept. And this, we just use the same method we normally used, where we make x is 0 for this, and we make y is 0 for this. And finding the x-intercept was a little bit harder, but very much doable. And then step 4 was just to draw the graph. And what I said was, I always started by kind of doing the guidelines of the field first, whatever they may be. And then I went and drew the shapes, and then I labeled. So I kind of did step 2, then step 1, then step 3, and I draw them. Give me a thumbs up if you feel like you remember all that from the previous lesson. For those who are new, you obviously wouldn't have seen it, but give me a thumbs up if that looks familiar. Okay, cool. Well, then let us look at a exam-like question. It's broken up in a slightly different way, but it's worth, it's quite generous marks. I don't know if I would give 11 marks always for this, but let's give it a go. I want you to try and do A, B. Well, let's try and do A and B. So first of all, do A and B for me, and then put your answers in the chat. So write down the equations of the asymptotes of f and calculate the coordinates of the x and y intercepts of f. I'm just going to get some, I didn't get water before the lesson. Okay, so we get x is 3 and y is 1 for A. And then for B, and so what are we going to get for this next? No. No. So we get minus 2 over 3 plus 1, which is a third. And the x-intercept is going to be what? 0 equals 2. And so this was the trickier calculation. But it wasn't terrible. You just had to be consistent. So I think what I'm going to do is I'm going to say that x is 1. So the x-intercept is 1 and the y-intercept is a third. So watch out for this x-intercept. It is a little bit sneaky. All right, now we have to talk about the domain and range of the graph. Now, we haven't spoken a lot about this. Would anybody like to give a little bit of comment, either on the chat or on audio? What is domain and what is range? What does that word, what do those words mean? They kind of always come up with functions, but does anybody have an idea? Who would anybody willing to share? So domain are your x-intercepts. So domain is the set of x values that are valid for the graph. And the range is the set of y values that are valid for the graph. So valid, what does that mean? Well, they take part, they're involved. That's what there's a more technical definition, but in a simple way, it's what x values can be involved are allowed to be involved and what y values are allowed to be involved. Oh, why is my thing keeping on switching? Sorry, I have to switch across here to my other. I'm going to unplug that one. I'll be with you in a second. And there you can see me again. Okay, so if I say to you, which values are valid? For this graph, as it stands right now, with the hyperbola, this is going to be a hyperbola. We haven't even drawn it, but there's going to be 2 places where values are not allowed. The one is there's going to be an asymptote when x is 3, and that's going to be that dotted line which you draw. And then for the y, there's going to be an asymptote when y equals 1. So if you want to write down the domain of the hyperbola, any x value is allowed. So we say x is any real number, except x cannot be 3. And the reason x cannot be 3 is because if x was 3, you would cause division by 0. Now for the range for hyperbola, y can be any real value, but y cannot be on the asymptote, so y cannot be 1. Okay. And then I just want you to take a moment now. Can you draw the graph for me? So I've given you the range. I want you to just take a moment to draw this hyperbola. And then I'm going to move on from drawing hyperbolas because I think you've all got the process fairly down. So when it comes to domain, basically you just exclude the x asymptote value. And when it comes to range, range can be anything except it can't be on the asymptote for the y asymptote. Okay, draw me my hyperbola. Mhm. What I think I need to do is I need to start by putting the lines in the field. And then I ask myself, I suppose I haven't done the step one, but step one should be like that. And what are we going to get here? So we need to label those 2 points. And what did I get for x? X was 1. That makes sense. And then what was y? A third, which is here. And then what is the name of the graph? The function's name is f. So why is your x vertical? Okay, well, because it goes through the x-axis, right? So the green one goes through the line y equals 1. If you imagine on the y-axis, there's like a 1 there. And so because it goes through, it's always y is equal to 1. That's why it is. Whereas the x, this is going through the point 3 on the x-axis. Does that help? So which was the first one you drew? It doesn't really matter which one you draw. You just have to have these 2 halves. Okay. They're both labeled F over here. Okay, now there is a little extra thing I want to tell you about hyperbolas. Now that I feel, actually, let me ask, do you all feel quite comfortable drawing hyperbolas? So thumbs up if you feel pretty comfortable, thumbs down if you feel, not so comfortable. I just want to get because I don't want to overwhelm you, but I do want to show you something else. And I do think there's something else that I can show you. Busisiwe, what's your question? Yeah. Can we unmute you, Busisiwe? Maybe that was just a hand saying, I know what's going on. Okay, now, there is something called an axis symmetry for hyperbola. And you may be saying, hold on, didn't you say asymptote? I'm like, well, there's two different, there's an asymptote. There's also something called an axis of symmetry. And in some ways, they're related. Let's just think about what an axis of symmetry does. An axis of symmetry, the last time I used that word was in parabolas, and it was kind of like a line in which if you fold across that line, it looks exactly the same. So the last time, let me actually zoom out of here for a second. When we were talking about parabolas, and I drew a parabola like this, there was an axis of symmetry going through the middle of the hyperbola because I could fold it over that and it would look the same. So just give me a thumbs up if you remember what an axis of symmetry is from earlier parabolas, because I need to make sure you know what it is before I start talking about it in the context of hyperbolas. Okay, now, if we look at this hyperbola that we are doing here, the axis of symmetry is going to go through the origin point, except the origin point has moved to here. So I'm going to call that point, let me call it O. I want you to write down what is the coordinates for the point O over here. This isn't a 0. Or maybe I should call it the point A, because O just looks like 0. So let me call it the point A. What is the coordinates of point A in this hyperbola? Pop it in the chat. So it's in line with x is 3 and it's in line with y is 1. Okay, so here is the first clue. The axis of symmetry goes through that point. Now, the other thing that's important about the axis of symmetry is going to be what type of thing it is, and it's a straight line. So it's going to look like this. So that is the one axis of symmetry. But there's also another axis of symmetry which goes like that. Now I'm gonna take it out of the picture, but I just want you to remember it for a second. So there's two axes of symmetry, but it's getting a little bit matted. If you look along the line, if you look along this yellow line, I know it's not perfect, but can you see how if you fold it across that yellow line, we basically get the same thing? Here's the really important thing. We call this the positive axis of symmetry, and the positive axis of symmetry is always going to have the gradient of +1. Now, you have a point that is on this line. That point is the point 3, 1, and it's over here. You also know the gradient of the straight line. I want you to work out the equation of the straight line for me, using the point 3, 1, and see if you can find out what the equation of the straight line is. Cool. Let me go to Tebogo. Tebogo, what is your question?
Hi, sir.
Okay.
For the axis of symmetry, is it always going to be a straight line?
Yes, it has to be a straight line. The only difference is for hyperbola, the axis of symmetry is going to be at 45 degrees or has a gradient of 1, which is different to the parabola. Yeah.
Okay, thank you.
Cool. So if you put 3, 1 in, I think, let me do the working up out here. We get 1 equals, what do we get? 3 plus c. And so then c has to be -2, which means the equation, and I haven't drawn this graph perfectly to scale, but the graph should be 1x minus 2. So actually, it should be going down a little bit lower. Now that is the positive axis of symmetry. Now, if I want the negative axis of symmetry, I'm going to draw it in for you on this side. And I'm going to put a little bit of green highlighter through it, just so you can follow. And the equation of this line, its gradient is going to be -1x. And it's also going to have a plus c, and you need to use the same point A that you used before. Find me the equation of the negative axis of symmetry. Figure that out for me. Okay, Busisiwe, what is your question? Or is your hand just up for a while? I'll try and unmute you. Maybe you have a question. Okay, Cass, what is your question? I see you have your hand up.
Okay, sir. So when you ask for the equation, do we have to find the gradients as well, or can we just put the symmetry in?
Okay, so the gradient for the axis of symmetry is always going to be 1 for the positive one, the yellow one, and it's always going to be -1 for the green one. So that you can take that back. The only thing that's different is that when your hyperbola shifts in different ways, the point where the asymptotes meet is going to be different. And that's why this is going to change.
Okay,
So
thank you.
Pleasure. So if we go and do a bit of working out here, we put a 1 here, we put a -3. Well, it should be -1 times 3. So let's do that. So -1 times 3 plus c. And then the -3 comes across and we get 4 equals c. So we get -1x plus 4. So the new bit of work that I wanted to show you today is it's not actually that hard to work out the axis of symmetry of hyperbolas. All you need to know is what is the new origin point And that you worked out at the beginning, it was 3, 1. And then you just need to know that the gradient of the positive 1 is 1, and the gradient of the negative axis of symmetry is -1. And then you work out the C value. Now, I will give you another chance later in the lesson to practice that, but I just wanted to give you a nice thorough introduction first. Let me go to Naledi, who has a question. Hi, Naledi, can you hear me?
Hi, sir. Yes, I can hear you.
Cool. What
Can
can
you
I do
hear
for you?
me?
Loud and clear.
Okay, so okay, sir. So I still don't understand how you got the 1/3 as your y-intercept on that question letter B.
Okay, so all you need to do to find the y-intercept is to make x 0. Are you okay with that idea?
Yes,
Make
sir.
x 0. So that, if you've got that part okay, then what you've got is you ignore the 0 and you've got 2/-3 or -2/3. And if you put in your calculator -2/3 plus 1, that's how you get the third over here.
Okay, sir.
Cool.
Well understood.
Perfect, perfect, perfect. Okay, now, before we go off and have our break, I want to squeeze in one more new idea. Now, you guys are getting very good at drawing graphs, and I want to just say that maybe sometimes, instead of actually having to draw a graph, you might have to figure out the equation of a graph. And so I want to just talk briefly before the break about how we might do that. Now, we know that the standard form of a hyperbola will look like that. And so in order to find the equation of the graph, we need to find A, P, and Q. If you look at this hyperbola, what is the Q value going to be? What do you think the Q value is going to be, and how would you know by looking at the Q, the graph? Could you figure it out from kind of working backwards? I think you're going to like this question. It's a bit easier than the ones we've been doing so far. Yeah, so Q has to be -4. Now, I don't know what A is. That's a bit of a mystery. But do I know what goes at the bottom here? If I look at it feels like you just used that one to help you, and now you have to use this one to help you. So if the x asymptote, sorry, if the vertical asymptote is going to be x equals -1, this has to be x plus 1. So it's not -1, it's going to be x plus 1. So it's actually quite quick and easy to get the Q value. And then the P value has a little bit of extra thinking, but it's not too bad. You just have to remember that it's what value of x will make this thing 0. And the only way this thing becomes 0 is if you have -1, which is what you wanted. All right, now here's the problem. Here's the only thing that's a little bit more tricky. I need to find what A is. The only piece of information I haven't used is this. Now, this is actually wrong. It can't be 0.6. It has to be 0-6 because it's below the x-axis. So that point should be 0-6. How can I use that point to help me find what A is? What do I need to do to help me find what A is? Yeah, so Kat has suggested, and we've done this quite a few times, you just sub it in. And so I'm going to put a -6 here for y, and then I'm going to put 0 plus 1, because there's a 0, and then there's a -4. Work out for me what the A value is. Work out for me what the A value is. What do we think the A value is? I suppose we have to clean this up a little bit. And that becomes +4. -2. Oh, and that makes sense because look at what quadrants, I'm in quadrants 2 and 4. So I'm glad that A is negative because if it wasn't, I'd be a bit confused. So what is the equation of this hyperbola? It's going to be minus 2 over x plus 1 minus 4. And so in some ways, finding the equation of a hyperbola is actually much easier than drawing the graph. And so we will do a couple more of these after the break, but yeah, I think from what I can see, you guys seem to have been following that. So Fateko was asked, how did you get minus 2? So Fateko, I took the naught minus 6, and the naught is an x, and the y is a minus 6. And so you'll see over here, here's a y. So now it becomes minus 6. And then the x, which was a 0, into that position there. And then I got, what's a over 1? It's a. So that's why I got that. And when the minus 4 came across, it became plus 4. And so you go minus 6 plus 4 is a, which gives you minus 2. What does it mean when an a value is a negative number? Okay, when an a is a negative number, it's going to mean that the quadrants that the hyperbola is drawn in are going to be in this quadrant and that quadrant. The a value also affects the shape. The kind of the bigger the a value is, the more it's going to be sort of bent, like it's going to be a more bendy banana. But that's not really something you need to worry too much about for now. Which quadrants the graph will be in? So Tebogo, we look at if a is positive. If a was positive, then I will be in these two quadrants. And if a is negative, I will be in those two quadrants. Now, when I say quadrants, obviously the quadrants kind of, I'm saying them in terms of the asymptotes. When they move, I'm saying in terms of those asymptotes. So it is a sense in which they've been shifted. But yeah. Okay, we have done a solid half an hour of work. I think we are all human. And so we need a little break. So let's stand up and just enjoy the fact that we can stand. Cool. Okay, let's just loosen up a little bit. Maybe like shake your arm a little bit. Feel like it's still alive. Is it still attached? Looks like it. Good for me. Shake out this arm. Maybe shake out some legs. Just if you've got pins and needles, get some blood flow down there. And then maybe a little turn. See that your stomach muscles are still there. And then let's do some circles, some small circles like this. Into some big circles. And then you can change direction with the big circles. And you can go down to small circles. You should feel your shoulders getting a little bit. Okay. And let's do a little arm stretch. Feel the burn a little bit. And let's do the side as well. Let's roll your shoulders. You can roll them back. And you can roll them forward. Okay, so hopefully your body is feeling a bit looser. Let's do some air skipping or virtual skipping, whatever you want to call it. We're just going to do 20 and we'll start in 3, 2, 1. Let's go. $16, $17, $18, $19, $25 more. 1, 5. And sit down and have a sip of your water if you're lucky enough to have some water standing by. Take a couple of deep breaths and let's have a bit of fun with a puzzle. No jumping jacks today, Fateko. No jumping jacks. All right, so tell me what a YouTube plus a Facebook times an Instagram is. I suppose this is getting a bit dated, hey, because everyone goes on TikToks these days or whatever that is. I'm not on TikTok, but I hear it's a thing. Okay. So YouTube is 7. It seems to me like, yes, YouTube has to be 7. Now, what is a Facebook? So now the thing that's tricky is that we have to go Facebook times 7 plus a Facebook is 72. Now, if it was 9 times 7 is 63. Oh, wait, you're right. So if 9 times 7 is 63, and then I add another 9, I get 72. So I indeed do get 9. So Lomax agrees, Fatejo agrees, Tip Piwa also agrees. Now, how much is an Instagram worth? So, helps to know your times tables here. So 8, Toboko said 8, so it's Quirin. So 8 times 9 is 72. And then plus another 8 does indeed give me 80. So we've got these 3. Now the last thing, what is that going to be? So again, we know the multiplication must be done first. So 9 times 8 is 72 plus the 7. So what is my final answer going to be? Yes, I see lots of people getting 79. So that was sort of a medium one. It wasn't as hard as the last one. But, oh, what about the small Facebook? Look at you. Okay, I'm going to disregard the small Facebook. I don't think the small Facebook plays a role, but that is a good spot. Well done. Well done, Kat. Your eyes on the prize there. Okay, so I think that is a nice, yeah, I know, Kat is like eyes on the prize. You'd be good at spotting animals if you went for a safari. Your eyes would like pick them up all over the place. Okay, here is a question for you. Here is a graph, and you are said the graph is drawn below, and they give you the rough format of the graph. And they say that there's a point T, which is on the graph. Find the values of A, P, and Q. So over to you to do that. Kilabukile, what is your question? Raise your hand and I can answer you, or you can put it in the chat. But it's often quicker to just raise your hand, and then we unmute you. So Kilabukile, if you go, I see Naledi has a hand up too. So if you just put I think you're putting Simone, what is the hand they have to put up? I think it's a different hand, hey?
Yes, I did DM, but I don't think it's seen. But if you are trying to raise your hand, you have to use a little reactions button. It's a smiley face with a little plus on the top corner of it. So if you click on that, and then you can click the hand in there, and then you will raise your hand so we can unmute you.
Perfect. Thanks. Cool. All right. So I'll wait for that. And then so we're trying to work out what is the equation of this graph. What did we do last time? I think we looked at the asymptotes first. That was our thing. Okay, Kilabukile, I'm going to unmute you and you can ask your question. Can you hear me?
Good evening, sir.
How's it going?
I'm okay. So today we were doing hyperbola functions.
Yeah.
And they gave us an equation here. It says y is equal to 2x minus 1 over x plus 1. And then they said we must sketch the graph. And firstly, we must write it in standard form.
Okay, wait. So are you asking a different question? Give
Yeah,
it
it's
to
a
me.
different question. It's 2x minus 1. Y is equals to 2x minus 1
Yeah.
over x plus 1.
Oh, okay.
Yes.
Y equals 2x minus 1 over x plus 1. So that, write it in standard form first. This is a different type of question. It might be a mistake because I don't think this is a hyperbola. This is a quotient function, unless you were factorizing it down. So are you sure 2x minus 1 over x plus 1? That
Yeah,
definitely
that's what they gave us in class.
okay. I'll have to get back to you in the next lesson because part of this makes me think of what worries me is how do I get this x over here and this x over here? And I don't want to go down that. I'm going to have to break it up into, yeah, over the x plus 1 minus 1 over x plus 1. I don't think this is I think there might be a mistake in this question because it's not
Okay.
looking like hyperbola to me. Not at the moment.
Okay,
I'll
sir.
take a screenshot and have a look later, but I'm going to stick to this question for now.
Okay, thank you.
Cool. Okay. So let's have a look at what this is. So if it's a 2 for the y, there must be a plus 2 here. And on the bottom, there must be an x minus 4, and then there must be an a. And then let's just make sure I've done that okay. Yeah, I have. And now I use the 0.53, and I'm going to sub that point in to help me find what a is. So I get 3 equals 5. No, 3 equals a over 5 minus 4 plus 2. And then 5 minus 4 is 1. So I get 3 is a over 1 plus 2. And in this case, then I get 3 minus 2 equals a, which is 1. So the equation of this graph is going to be y equals 1 over x minus 4 plus 2. Why is 4 negative? The reason the x minus 4 is negative is that the asymptote is positive 4. And so when you put positive 4 into this, positive 4 minus 4 gives you 0. And that's why it's undefined. That's why the asymptote, the vertical one, has to be on x is 4. And we're not allowed to cross that line because it causes division by 0. Okay. Now, I want you, this is an extra question. I want you to find me the positive, wait, it's not going through that point. Let me take this out. I want you to find me, let's put it this way, actually. Find me the negative axis of symmetry. So this is the axis of symmetry for the graph F. I want you to find me the equation of the negative axis of symmetry. Go for it. What's that going to be? So why is the 4 negative? So when you work with the asymptote going through the x-axis, you have to ask yourself what needs to be in the equation that when I put that value 4 in, it would cause division by 0. So if you're putting 4 in here, 4 minus 4 is 0, works fine. Okay. If you had something else there, it wouldn't work properly. So if you put here x plus 4, then when you put a 4 in, you wouldn't get 0, you would get 8. And that doesn't cause an asymptote. So to get an asymptote, the value, when you put it in, has to cause division by 0. So I hope that. So for Techo, the axis of symmetry is it's a higher level question. But because you're in the standard class, I do think it's important, like, if you want to get from like a 50s to a 60s or 50s to a 70s, this is the type of question that you have to get right. Yeah. Okay, so we know it's going to be minus x plus c. And the point that we're going to use is not the 0.53. The point is going to be the 0.42, because that's the point that it has to go through. So now, how do I use that 0.42 to help me find the equation of this axis of symmetry? I suppose we just, the one thing about functions that I love, it's so repetitive in a lot of ways. Like you'll see here, like you put a 2 for the y, and then you put a minus 4 plus c, and then that comes across and you get 2 plus 4. So you just sub the point in and you get 6. And so the equation of the negative axis of symmetry is minus 6 plus 6. You see, it's not so bad. It's like, it's combining your knowledge of straight lines and you kind of mixing it in with your knowledge of hyperbolas. So Fateka was asked, how and why is it negative x plus c? The reason is the axis of symmetry will always be at 45 degrees. And the reason it has to be at 45 degrees is that it has to be the equal size. If you're going to fold it over, it has to be the same size angle on either side. And since you know this is 90, then what's 90 divided by 2? But I don't want to go too deep into it because I feel like it's going to cause more confusion than understanding. Should we do one more like this? Let's do one more like this. Let's do this one. So find me the equation of this graph, and then also find me the positive axis of symmetry. I haven't actually drawn that properly. Let me try and draw that a bit at a better angle. So find me the equations of these two hyperbolas, or this hyperbola with its two halves. And then after that, find me the positive axis of symmetry for that hyperbola. Let's go to Awetu. Awetu has a question. Awetu, what is your question? Can you hear me?
Yeah, I can hear you. I think we already passed that. Like, you already explained what I wanted to. Thank you.
No problem. I'll give you a hint with this one. You know that the one asymptote is y is 2, but the other asymptote is x is 0. So these are the asymptotes. The sneaky thing is that the one asymptote, they're not showing you because it's actually on that y-axis. So think about how that'll affect your answer. It doesn't matter if they equal minus 0 or plus 0 does the same thing. So you're going to get a over x plus 0, but x plus 0 is really just x, or it could be x minus 0. It basically just becomes y equals a over x, and then this is going to be plus 2. But I need a point, and I've just figured out that there's actually a point here. And that point's coordinates are going to be 2, 0. And you can use that 2, 0 to help you find what A is. So you can tell me in the chat what you think A is. So what do we get here? Naught equals a over 2 plus 2. So naught, not naught, minus 2 is a over 2. And if I multiply that 2 across, I should get a is minus 4. And so the equation of my graph is negative 4 over x plus 2. Okay, so that's not so bad. Now, I want my positive axis of symmetry. I want that line. I want you to figure that out for me. Michaela, wouldn't P be minus 2? Ooh. No, it wouldn't. Because in this case, the reason is, Michaela, is that this asymptote hasn't moved at all. So in this case, P is 0. P is actually 0 because it's just stayed exactly where it is. The only one that's moved is Q, and it's moved from here up to here. So it's gone up by 2 units. So I hope that helps a bit, Michaela. So we know that this is going to be x plus c. We need to know what that point is, and I think the point is 0, 2. But you know what? I don't even have to sub this in. I can if I want, but I can actually see that this is the y-intercept. The y-intercept is 2. Now, if you subbed it in, it would work. You would just say 2 is equal to 0 plus c, in which case c is 2. But the equation of my positive axis of symmetry is just going to be x plus 2. Okay. All right, everyone. Let me ask you, should I ask you some more? We've got 2 or 3 minutes. Let me make some more questions up for you on this. I want to know, what is the domain and what is the range for this hyperbola that we've just solved for? So tell me what the domain is and tell me what the range is for this hyperbola that we've just, or did I just wipe out? Let me undo that so that we can go back. Oh, it's not coming back. So it was, I gave you this hyperbola, which was y equals minus 4 over x plus 2. I want to know what is the, what's at the bottom? What is the domain and what is the range of this hyperbola? So domain, what is the range? Well, x can be any real number except x cannot be 0. And what about the range? Y would be any real number, but y could not be what? Wherever there's an asymptote, so y cannot be equal to 2 because it cannot be, the graph itself cannot go across that dotted line. Okay, so that's a domain and range question. And actually, it's not so bad there. So we've learned, if you look at what we've done today, we started out the lesson by drawing hyperbolas and making sure we knew the 4 steps. Then I spoke to you about this idea that a hyperbola has an axis of symmetry, which we can work out, and it's a straight line. And there's 2 of them, and we can work out both of them or one of them at a time. Then we spoke about finding the equations of hyperbolas. And it seemed to be that all we did was we looked at the asymptotes and we worked backwards, and then we just plugged one point in, and then we'd find the things for my the hyperbolas. And then knowing about domain and range related to hyperbolas is also something that we discussed. So Tebogo has asked, why can't the range be y is greater than or equal to 2? Well, here's the problem. If you say that the range is greater than or equal to 2, you're saying that the graph only exists in the place where that red thing is. But look below it. I think the graph doesn't exist. The only place it doesn't exist is on this asymptote, which is at 2. But if you look below that, this is still part of the graph. There's a y value that goes to that and that. So that's why you say the range is any real value, any number, except it cannot be y is 2. All right, cool. Simone, could you put the link to the quiz in the chat? If there are any final questions, I will take that now. But again, we've done a good solid week on hyperbolas. If you do the quiz, you'll reinforce your understanding. And next week, we do our final function, which is the exponential function. And then as time allows, we'll also do some combined questions where we try and mix the functions together. I really encourage those of you who have missed lessons, go back and watch the earlier lessons. This topic can be such a wonderful topic once you get your core fitness up, to use a sort of gym idea. Like once you've got that core, a lot of the stuff becomes repetitive. Okay. Fateko, I don't think there are too many old videos on exponential. There might be some in the exam revision, but I don't think we explicitly covered it before, no. Why can't the range be y as an element of infinity? Oh, okay. Okay. But y is an element of infinity to 2, minus infinity to 2. The problem is that you've only got one half of it, right? So if you go from minus infinity up to 2, then you also have to go from 2 to positive infinity. If you put those two together, that is the same as this. But it's so much longer. My suggestion, why would you want to do it with interval notation when you can do it using the Setbulder notation? So it's so quick. So you only give me one of the answers there, yeah. So Tato, triggers in paper 2. Triggers in paper 2, there's a lovely big section on paper 2 that we've done already. All right, everyone, it was lovely teaching you today. And again, well done for showing your commitment and being here. Good luck for your exams. And again, do the best you can, and then also allow yourself some space that you're already working hard. And you're controlling what you can control. The other stuff you can't control. But I know it's so much easier to say than it is to actually do. But you will get better if you keep practicing. So you just have to run the marathon. All right, pleasure, Lomex.